Alrighty. Hi everyone. Welcome to What's New with Kotlin Multiplatform Libraries. I'm Russell Wolf. I'm a multi-platform developer at TouchLab, where we're focused on building Kotlin multi-platform mobile apps. So excited to be back at Android Summit. I spoke here last year as well, also on multi-platform stuff. I'm gonna try to watch the Slack chat a little bit while I'm giving the talk, just in case anyone has issues hearing me or anything. So just like feel free to chat out or bug Etienne, because he'll be more on top of that stuff than I am. But let's just get started. Kotlin Multiplatform starts with Kotlin. We're an Android conference, and we heard in Chet's keynote about Kotlin on Android. So that's Kotlin running in the JVM environment, where you get that nice Java interop, where you can talk to Java APIs, you can talk to Android APIs that are written in Java, as well as talking to your Kotlin code. And that is, we know, the preferred language for Android development, the preferred kind of way that we write Android apps these days. But Kotlin is not just a language for JVM or for Android. It is multi-platform. Multi-platform Kotlin is a language feature that enables you to share parts of your code to different platforms and have them run in different environments. So there's a concept of common code, which can be built for multiple targets, usually for any of those targets. And so that might be JVM or Android, that might be JavaScript, that might be iOS, or other like native desktop or embedded systems. And then there is platform-specific code, which can talk to those individual platform-specific APIs. So just like Kotlin on the JVM can talk to Java stuff, Kotlin on iOS can talk to iOS system APIs. As of Kotlin 1.4 last month, multi-platform Kotlin is officially graduated from experimental status to alpha status. So you should start using it, right? So a subset of Kotlin multi-platform is kind of the mobile space, which is where I spend most of my like day-to-day professional work. So that's specifically Android and iOS. That's the sorts of stuff that we're used to in an Android conference where we're thinking about mobile things. I've been saying for a while, I think, that mobile really is like the killer app for a Kotlin multi-platform, because like Kotlin multi-platform is awesome for, you have all these different platforms that you want to be able to share some parts of your code to, where you have kind of like complicated business logic or other things that you don't want to implement twice. But what's really nice about mobile is there's quite a lot of kind of parity between those platforms. So like if you're sharing between server and client on web, like you might be sharing some validation logic and some data models, but you have two environments that are doing different things, and so you're not going to share as much. On mobile, you typically have apps that your users or your product managers want to be as similar as possible. So you have that same use case and you have kind of similar capabilities across these devices. And that's, I think, where Kotlin multi-platform really shines. So what does this look like conceptually? I've recently become a fan of this kind of Venn diagram model of it. So you have your, on the left side, you have the Android JVM code that you're used to. And a subset of that is these common APIs that don't have any concept of certain platform-specific things like files, like threading, though some of that can kind of come in from libraries. But it's stuff that can be built to whichever platform you want. And then the other side is you have iOS, which can consume those common APIs and then talk to the iOS system itself. And so that all comes together and gives you this kind of flexible way to share probably not all of your code, but the parts of your code that make sense to share in a very flexible way. So what does this look like in code? So in the simplest cases, you can just kind of write common code. So it looks fairly similar to what you're used to. You have classes, you have vals, you have functions. You can talk to things like the collections API and do little bits of mostly like pure logic code and run that everywhere. But sometimes you need to do something that is platform specific. You need to persist something to disk, or you need to like spin up another thread or something like that. And there's a couple different ways that you can do platform specific code. So the keywords that multi-platform adds to Kotlin as a language are expect and actual. So in your common code, you can expect a declaration. Here it's a value, but it could also be a class or an interface or a function or anything else. And the individual platforms can each provide their own implementation of it. And the build system is responsible for kind of like replacing all of those expect declarations with that platform's actual. And so that's very convenient for like spinning up certain things quickly for kind of like configuring your top level dependencies. But you also have the ability to still use all of the tools that you're used to from Kotlin. So for example, you can just define an interface in common and give it separate implementations on the different platforms. And this has some nice advantages. For example, you can implement an interface in Swift instead of Kotlin on the iOS side, if you so choose. And you can add extra implementations. So expecting actual needs to be one-to-one per platform. So there can only be, if you have a expect class logger, you can only have one logger implementation ever on Android and one implementation ever on iOS. And if you use interface, you can have others. So if you want to have like a separate thing that you pass in for tests, for example, you have flexibility to do that. So what does this look like at sort of a higher architectural level? So in the center, you have these three boxes are essentially the Venn diagram from before. You have your shared code module that on the Android side is going to build a AR Android library. On the iOS side, it's going to build a framework, which is the iOS dependency format. And then your applications consume those dependencies like they would any other library. And you even could have your like shared module build the Android app directly, but usually it's nicer to still have that separation the same way you do on the iOS side. And what's really nice about this setup in general is like the real selling point for multi-platform in my eye is none of the rest of your code needs to know about this. So nothing is stopping you from pulling in any other dependencies that you might have on either platform or any other code that you might want to write. Like the stuff that you're sharing doesn't need to have any bearing on how you build the rest of your app. And of course, in addition to pulling in the different platform-specific dependencies, you might have common code dependencies that you talk to from your shared code. And that's actually what I am focused on for the rest of this talk is what are the libraries, or how do you build libraries that your shared code can talk to? So there's a bit of a kind of funny nomenclature thing that I see sometimes where often you see people talk about like the shared library of their Kotlin multi-platform application. And there's both the library on the top here, which is like your application's shared code between your Android and iOS, but there's also the concept of a a multi-platform library, which is like the dependency that you can depend on in your multi-platform code. And that's the piece that I find, or that I'm talking about here. So what is kind of my story with all this stuff? So way back in the winter of 2017, before Android officially supported Kotlin, the kind of like nether days, I'd been developing Android apps, like native Android apps professionally for a little while, and I happened to end up on a React Native project, which I was not a very big fan of, and I won't go into too much detail there, but it got me started to think about, like, I didn't really like the way that React Native did code sharing, but what would I like in a code sharing framework? And then around that time, the very first preview releases of Kotlin Native came out. And so I kind of started watching that out of the corner of my eye, messing around with things. And over the course of the next year or so, they slowly started to build that up. And in parallel, the multi-platform framework had been introduced in Kotlin 1.2, but initially just for JVM and JavaScript. But in 2018, in Kotlin Native version 0.6, they finally integrated Kotlin Native into multi-platform, so you could actually not just run Kotlin on native platforms, but also share Kotlin between your JVM, your JS, and your native. So that was the moment that I really started to jump in and say, like, okay, can I, like, what can we do with this? I took our kind of like skeleton starter project at the company that I was at the time and tried to do like a Kotlin multi-platform version of it. And one of the things that came out of that was there were different Android dependencies that we needed, that needed to be kind of translated to iOS, one of which was shared preferences. So I had some code in there to find a thing in common that was shared preferences on Android and was the equivalent iOS API, which is called user defaults on the iOS side. So I had that in application. I started thinking about like what pieces of this could be pulled out and componentized. And part of my inspiration there was long before I was actually working at TouchLab, kind of watching Kim McGalligan, who is a partner at TouchLab, was I think at the time president, who was doing lots of blogging and conference speaking about this stuff, and talking about we're going to need libraries for this new ecosystem. So a couple months go by, I'm thinking like loosely about libraries, and in the next Kotlin Native release, they were building out more of like the memory model that has gotten various bits has generated various bits of controversy over time, and that they're now like starting to rewrite. But buried in the release notes, like not even in the blog post, but like somewhere in the like Git release notes, was this line about being able to deploy klibs, which are the Kotlin native dependency format, as Maven artifacts. And what that means is this was the moment that you could actually like publish a library and consume it in the way that we're used to as Android developers. So I did. So about a month later, I put out the first version of Multiplatform Settings, which is key value storage based on these different platform APIs. It's a pretty thin library ultimately, like it doesn't do a lot. But it's kind of one of those things that comes up often when you're writing mobile application code. And in addition to like the raw wrapping of the different platform APIs, it has some like nice content Kotlin syntax helpers. So there's like operator functions, so you can use like the bracket syntax to call your setters and getters, or property delegates, which I'll show some code for that in a little bit. It's on GitHub there if you want to like dig in and look at it or throw up issues. So here's kind of like a rough sketch of what things look like. So there's a there's a common like an interface defined in common called settings, and that's built for every single platform that Kotlin builds to. And then some of the platforms have implementations. So on Android, there's an implementation of this interface that wraps around shared preferences, and like when it is setting a value, it calls into that. On iOS, there's a wrapper around user defaults. So those two were what was kind of there initially, and over time I've added more. So there's a JavaScript implementation that wraps around local storage. There's a JVM. There are actually two JVM implementations. This one wraps around the preferences API. There's another one that wraps around the properties API. So if you're sharing code, like maybe between client and server, or if you're just doing something else, JVM on desktop that you want to have the shared API for, you have that available. More recently, I've added a Windows implementation, which, let me tell you, it is a lot of fun dealing with the native Windows APIs. But that's there now. It ends up being much more complicated than most of the rest of them are. So that put registry value function in there is a helper that I have that's doing a lot more work than you can see from this slide. And in addition to all of those like production platform implementations, there's a mock implementation that's just wrapping around a map, so that if you are writing a application that's using this library and you want to be able to like write tests that interact with the settings interface but don't actually persist things to disk, you can pass mock settings instead. And that's actually available. That is available on every platform, not just on the platforms that have production implementations. So if you want to supply your own implementation for your use case, you can still use the mock to test it, or to test your logic that's interacting with it. And then I said before, there's these other like syntax helpers, so operators that you can use that kind of bracket syntax, and delegate, so you can have a variable that's like backed by your settings internally, but just looks like a normal property externally. Let's sketch of what the library is. What are some of the sort of things that I've learned along the way of building it? So this was my first time kind of like maintaining something open source that other people were depending on, and which is like honestly a really fulfilling and satisfying experience. But like you make mistakes along the way, and you learn things to pick things up. So one of the big learnings that I had that I like to talk about whenever I give this talk is around using expect actual versus interfaces. So when I like put out the first version of the library, settings with an interface, settings was a expect class, because like expect actual is the shiny new tool, and so like everything, like when you have a shiny new hammer, everything feels like a nail, is the way I like to say that. And I ran into the problem that I described earlier, which was if I'm writing an application that's using it, I can't mock that out. So I refactored this in multiple steps. At first, I just pulled an interface out and still had an expect class underneath it. But there's not really much value to that. The one tiny thing that it can get you is like it lets you define a comment constructor, if that's something that you care about. But I wasn't, because you actually need to pass different platform-specific things into the constructors of these classes. So what I eventually moved to is just having an interface and the separate implementations just defined in the platforms. Another kind of early piece of work that's a nice like library level experience is the very first feature request I ever got was talking about adding change listeners. So initially I just had like the raw setters and getters, but what if you want to be able to subscribe to updates, which both the Android and iOS APIs give you the ability to do. Seems like a really nice idea, but it turns out Android and iOS kind of have very different ways of doing these sorts of updates. So Android, you may know the on shared preference change listener interface, which basically it tells you what key is updating when a change happens. And it has this sort of ambiguous documentation where it says, like, if you get the same value back, you might or you might not, your callback might or might not get invoked again. iOS, on the other hand, has this this kind of like global event bus called the NS Notification Center that you just kind of pass notification objects to that don't, and this notification doesn't have any data on it. It just says something in the user defaults that you were listening to changed, and you're responsible for looking and seeing what. So with these kind of like very different ways of operating, it gets hard to like, how do you define a shared interface that your common code can call? And so what I ended up doing is letting the user define a call, like the client library defines a callback that is that specifies what key it wants to listen to, and then both platforms listeners can, when they see an update, check, like cache the old value of that key, check if it's changed, and then call the user's supplied listener if it did change. So it's slightly different than the behavior that you get from either of the platforms, but it's done in a way that both platforms can have the same behavior, so that at least you kind of have predictable behavior of your shared code. And that sort of trade-off comes up a lot when you're doing this sort of wrapping different platform interfaces. So this is kind of my favorite example of that. So that was all well and good when there was just Android and iOS in there, but then JavaScript came along, and the JavaScript storage APIs, they actually do have some update listener functionality, but it doesn't work with within the same browser window, which is likely what you would be looking for if you're using these same APIs on Android and iOS. So suddenly there's a problem. Like, how do we handle the fact that we can't do something in one platform that we can do in the others? So what I ended up doing was that this was another kind of advantage of having an interface at the root of everything. You can define a separate interface. So all of the listener APIs, I moved to this observable settings, which Android and iOS can implement because they know how, but JavaScript doesn't. And similarly, like right now, the Windows implementation is not observable, but one of the JVM ones is. Another example I like of sort of API design decisions, when I first kind of wrote out the settings APIs, I'm historically an Android developer. And so like I base the interface mostly around the way that shared preferences works. And so that's, you pass a key and you pass a default value that you expect to get back if that key is missing. And to kind of try to simplify the API, like I let that default value, like I made it so you don't have to pass that default value, and you can just like default to 0 or to, so that makes sense depending on the data type that you're using. But what you might want as a user actually is to just get null back. So in retrospect, I kind of wish I hadn't done that equals 0, because I could have just had a version of a function just called getInt that you pass one parameter to, that's then has a nullable return. Because I already had that default value in place, that default for the default value parameter in place, I couldn't do that in a backwards compatible way. So I ended up adding like get or null versions of these things. So it's a little bit more verbose, but it gives you that functionality if you want to get null back instead of getting a default value back. So depending on what your use case is or what style you're more used to, you can take either one of those. So I talked a little bit about the box settings API earlier. One of the things that's been important for me as I develop all of this stuff is making sure that all of the different setting implementations are well tested. And so I have a kind of big suite of unit tests that like all of the different setting classes pass. So there's like a shared base class that gets extended for each one, so that they all kind of run through those same tests. But when I added when I have the mux settings, like that's in most cases just going to be a test dependency. So I wanted it to be in a different module. But then how can its tests depend on the shared test class that the main module was using? It turns out Gradle in Kotlin Multiplatform doesn't give you the ability to depend on another module's test sources. So I can't do something like this. What I ended up needing to do was add a separate third module where those shared tests are defined in the main sources. So that depends on the main source of the root setting module, and then the test modules can all depend on that to run those shared test cases. It gets kind of convoluted, and there's some subtle ways in which this sometimes breaks certain other Gradle things. So I don't recommend doing this unless you find that you need it, but like for my use case, it felt worthwhile. But like if you're building a library and run into this sort of setup, just like be aware that sometimes it breaks other things in Gradle. So most of the stuff that I've gone through thus far is things I've talked about some in the past when I've given other versions of this talk. What's some of the new stuff that's going on lately? Because there's been a lot of cool developments, especially with the Kotlin 1.4 release. So one of the things that I want to talk about is this concept of the hierarchical project model and Gradle metadata. So these are terms that you'll hear thrown around a bunch if you're reading through different parts of the multi-platform documentation. And what it really means is, so we were looking earlier at this kind of like central module that has different source sets for Android and iOS, and we're going to like pick it apart a little bit, because once you zoom in, iOS, and this is true for most of the really for most of all of Kotlin's platforms, is more than one thing. There's separate native architecture in iOS for devices and for simulators, and for older devices, there's a split between 32-bit and 64-bit. So iOS is actually 3 different Kotlin native platforms. And once you zoom out to like the wider active ecosystem, there's also macOS, there's tvOS, there's watchOS, all of which share most of their APIs, but have some subtle differences. And what you would like to have is a place where you can kind of put your shared iOS code that's still specific to like the iOS family of platforms. So it's not like common to everything, but it is shared between those things that do care about it. And it actually goes a little bit further because you have that 32-bit versus 64-bit distinction, and sometimes you need to do different things depending on that. If you're talking to an iOS API that talks to a type like NS integer, that is a Kotlin int in 32-bit, but it's a Kotlin long in 64-bit. So Kotlin native translates these things differently, and so your code that's talking to those APIs needs to change. So if you're working in a complex enough multi-platform environment, whether it's library or an application, really, you may need to have these sorts of splits. So the idea, like the way that that's done is like the Gradle plugin and the compiler are able to match all the right things together when you kind of configure all the sort sets in this way. But historically, the IDE doesn't really know how to parse the intermediate ones. So it knows what comment is, it knows what the like leaf level platforms are, but it doesn't really know what's available in those intermediate ones. And so the hierarchical project model is this like is the ways that like Gradle exposes more of that to the IDE so that you can like get your correct autocompletion and stuff in your code in those source sets. So they've added more support for that in 1.4. A lot of it is still in progress, and I've had trouble kind of getting some of it to work as well as I would like. One of the current limitations still is that like the commonizer engine that's kind of figuring out what is shared between different native platforms. It knows how to do this at one level, but not at 2 levels. So it can do this version, but I can't really do this version yet. But there's kind of various ways you can hack around that sometimes. The real point I want to make, though, is most of the limitations here are at the IDE level. So like the compiler has always known how to do this sort of thing as long as you wire up the dependencies correctly. So you've always been able to write your code this way, and there's kind of like, there's not a lot new in kind of being able to publish libraries that share code in this way, for example. But what's being added is the ability to, like, the better IDE support for it. And relatedly, there's the one of the things that JetBrains changed in their library publishing with the 1.4 release was they added they basically, like, they gave you kind of like a single common dependency that, using this Gradle metadata API, is able to figure out how to match to your different source sets automatically, so that you don't need to kind of specify each dependency for each platform. And that, again, like, that's been around actually for like a year and a half or so. But the JetBrains libraries were not publishing in a way that took advantage of it. So like, that's changed in JetBrains publishing process, but like, it's not actually a new feature for multi-platform. That's my little like soapbox, because I've been publishing that way for a while, and as had been a lot of other people in the community. So the way that this stuff is configured, and this is my kind of like moment of shame for my talk, I wanted to really dig in and understand these different parameters better. So they have these different Gradle properties that you can pass to configure this stuff. And I had trouble kind of getting good, consistent minimal samples to like really tease apart the behavior of these different flags. But like, in brief, based on how they're documented and some different Slack conversations with the native team, those first two flags, the top one is essentially around generating kind of a common metadata artifact, so that consumers can depend on that and see what code is available at that intermediate source set. And the second one, the Kotlin native enabled dependency propagation, is around how the compiler figures out which platform dependencies are available to each intermediate source set, kind of like intersects between the different iOS platforms to see what's shared between them, for example. And so those two are documented in spots in the Kotlin Multiplatform documentation on the Kotlin Lang site. The third flag, I don't think I've seen officially documented anywhere, but what is supposed to do is, if you are a library that's publishing with metadata, it publishes in a way that's compatible to consumers who are not using it. So if your consumers don't have these flags enabled, they can still use your library that does. So I don't understand these as well as I would like to, and I haven't gotten them kind of like working as well as I would like in my library. So like, Multiplatform Settings right now has trouble building when that second flag is enabled. But they are there, and they're kind of like the intended ways to work with this stuff. And they'll eventually become the default, but they aren't yet. So other cool new stuff that we've gotten recently. So for a very long time in the multi-platform world, we're always saying like, documentation is super out of date. Like, don't look at anything that's more than 6 months old. And actually that last point might still be true, but with the 1.4 release, JetBrains put out a lot of new documentation on things. So if you've been avoiding looking at that site because you don't trust it, give it another look. There's a bunch of new stuff in there. There used to be that like building MPP with Gradle page that I would always link in this talk. That was like the one Bible that was always getting up to date on how the Gradle stuff is configured. And that page doesn't even exist anymore because it's been subsumed by this like multi-page site that has a bunch of information in it. They also have some new docs specifically around migrating to 1.4, which can be nice if you haven't updated yet and you're having trouble with things. One thing I really want to highlight there for library developers is they have some tips specifically on if you've been using the old bin tray plugin to publish and you want to migrate over to either migrate to Maven Central entirely or just migrate over to using the Maven publish plugin. They have some tips around that. or around making sure that you can get the multi-development working, because it has some bugs with multi-platform. And then specifically to mobile, there's this new Kotlin Multiplatform mobile portal that has a bunch of information around using Kotlin Multiplatform for Android iOS code sharing and some of the dependency ecosystem there. So what's on kind of my to-do list with all of this new stuff? So one thing I've had in progress for a while but haven't like actually published yet is integrations with coroutines and flow and with Kotlin serialization. So the first would let you like use a flow to listen to talk to the update listeners. The serialization would let you kind of serialize larger objects to your settings store rather than just primitive values. I've held off on publishing those as some of the APIs that they're talking to have been stabilizing. But for example, Kotlin serialization actually just published their 1.0 version today. So these are probably stable enough now that I can finally actually publish them. I'm also always thinking about like what other platforms are available to publish to. So one that's come up a couple times that people ask about is having like a secure store instead of a plain text store. So on Android, you can just use encrypted shared preferences from the Android X crypto or Android X security. On iOS, there's these keychain APIs that I would like to write a wrapper around. There's some other community implementations that exist in spots, but I haven't found one that feels easy to integrate into what Multiplatform Settings currently has. I also would very much like to have a desktop Linux implementation, because that's the one desktop platform that doesn't exist right now. I have a prototype of a thing, but I don't know if it's talking to an API that people actually find useful. So if you do desktop Linux development and are interested in this library, please talk to me. Lastly, Android just put out this new, essentially shared preferences replacement called Data Store, which is like purely coroutine based and completely asynchronous. And I would like to find a nice way to integrate with that. But it behaves very differently to the other existing implementations, so it's going to be some work. So what about other stuff? We're coming up on time, but I will try to be quick. So JetBrains, of course, always puts out kind of their core libraries. The big three are Kotlin coroutines, which gives you your async stuff, that like the same way that you're used to on Android. Kotlin serialization, which is your like your JSON serialization or your whatever other like protobuf or other format that you might want to serialize to. And then KTOR is your HTTP client, so like your retrofit replacement in the multi-platform world. They just put out the like first alpha version of a datetime library, so that's been kind of like a long time ask from the community. So it's nice to kind of finally have that in place, or like starting to be in place. Definitely try it out and give them feedback and tell them what is missing, because it's still pretty bare bones. And then they have like some IO and atomic stuff that is like not their like big public facing priorities, but it's other stuff that's kind of happening in the background. And then this is where I usually like try to put a list of like the major community libraries. So like we at TouchLab put out a couple things, some tooling related stuff like the Xcode debugger, some kind of like application infrastructure stuff like Stately, which helps you work with different, work around the Kotlin native threading model essentially. Instead, the ecosystem is kind of getting big enough that it's easier to just like link to where there's lists of things. So that first GitHub repo for a while has been like a nice community maintained list of libraries that are out there. And then there's another page on the on that official Kotlin linking site. And maybe in the future also yours. So like it's really neat to kind of jump into a young ecosystem and be able to contribute to it. And I hope by talking about some of my experiences, I can inspire some other people to do that. So that might look similar to the way that Multiplatform Settings does, like wrapping around platform APIs, where you have an existing implementation. So all you have to do is like figure out how to make them behave the same. Or you can just kind of do something in pure Kotlin. Like if you have a library that's like, maybe it's like an architecture thing or like a mathematics thing, and you can just write it in common code, then like you put the effort into building your new implementation, but if everything's in common, then you get every platform for free. But whichever you do, like now is a great time to do it. The ecosystem is growing, but it's still pretty young. You can kind of make your mark in a lower effort way than you would be able to a couple years from now. So I recommend you try it out. Thanks for coming to my talk. I guess I used up all of the time, but I will definitely hang around, answer some questions. You can see the link to my library right there, and some other useful links. And I want to plug next week, JetBrains is doing their big Kotlin 1.4, essentially like Kotlin Conf replacement online event. So there's going to be a bunch of good talks there. Check that out if you want more conference after this conference. So yeah, thanks for listening. Thanks, Andrew, so much for hosting me. Yeah.
I was just going to say, if you want, we can leave the room open for another 15, 20 minutes if you want to open it up to Q&A. I saw Kenneth Brewer had a question in the chat. How does Kotlin cross-platform compare with Flutter? Does one over the other seem to be the future for development?
Sure. So I like to answer that by saying they sort of solve different problems. Like Flutter is very much about writing a UI layer that you can kind of that you can use on multiple platforms and writing it once and sharing all of that code. Kotlin is much more, it's better tuned for kind of like the lower, like the logic layer of your app, kind of lower level stuff. But it's much more flexible, where it's easy to kind of move in and out of your shared code, depending on what you want to do. So like if you're in Flutter and a new native API comes out, it's going to be a lot harder for, like, you're going to have to either wait for someone else to write the library that bridges into it, or you're going to have to figure that out yourself. In Kotlin, you can just
home roll your own plugin, then, right? Yeah.
Yeah.
Cool.
Yeah, you have a lot more flexibility to do that yourself.
Do you want to take a look at some of the chat questions that have come in and just pick from that list?
Yeah, I will drop my share.
I know you're juggling screens here.
Yeah. Now if I drop the share, then I can see it.
There we go.
So what else do we get? Is there any way to get? So yeah. Someone asked, is there any way to get generated metanames to be not so verbose? Not currently that I'm aware of. I think there's a UTrack ticket for like on the JVM. There's like the JVM name annotation where you can say like, tell Java that the name of this method is this, so that it's shorter. And I think there's a JS version of that too, but there's not a Objective-C one the way that iOS would need. But I think there's an issue for that you can upvote. If you look for that and you don't find it, add one, because I agree we could use that. But by default, there's not an easy way to do that. Question around how long until this becomes more mainstream. I think that's always hard to guess. But I think we are seeing it become more mainstream. Like one of the things we're noticing at TouchLab that, especially since like the alpha announcement, that more and more of the clients that we're talking to are getting interested and are feeling ready. You are definitely an early adopter if you use it now, and that's why it doesn't feel very mainstream. But it is growing, and I think it will continue to grow. is there a difference between Kotlin native and Kotlin multiplatform? That's actually a slide that I have had in that intro in the past, but I cut out. So Kotlin multiplatform is the framework of sharing code between the different Kotlin platforms. Kotlin native is one of those platforms. There's really like a family of them. So like Kotlin native is running Kotlin on iOS, for example, or running Kotlin natively on desktop without a JVM. Kotlin multiplatform is like adding in that common source set and building it to the native platforms or to JVM or to JS. Do you know any open source library that uses Kotlin multiplatform? Yes, that's what I was talking about. That was mine. Like there's a lot. That last, or one of the links on that last page, and also earlier in the talk, is one of those lists of different community maintained libraries. So it's not a huge ecosystem. It's not nearly as big as like Android libraries, but there's stuff out there that will hit a lot of your common needs. And there's room to add your own if they don't. Is it best to use a cross-platform UI system or incorporate native libraries? What we do tends to be writing your UI natively, but it's really up to you. Like there are people that talk about like putting like a Flutter UI on top of a Kotlin multi-platform backend. The thing that is awesome about Kotlin is you have the flexibility to kind of pick and do it however you want. What else is there? Did you have to learn iOS on the side to test out your local storage library? Yeah, so I largely picked up iOS stuff as I was getting more and more into multi-platform. I'm definitely much more comfortable on the Android side typically, but as you do more multi-platform stuff, like you find yourself picking up more of these things, and it's this nice kind of transformation where you can start thinking of yourself less as an Android developer or an iOS developer and more as a mobile developer or just as a developer. Like it sort of gives you the superpower of being able to hit all of these different things. And you still do need the people who have the platform specific expertise, especially when you're getting into like the Android specific or iOS specific like Arcana. But it's really cool to know enough about both of them and be able to build to both of them. Apps that are open source that we can look to for best practices. Yeah, so TouchLab puts out a thing called Camp Kit, which I think Kevin is talking about in his talk that's starting up right now. So I definitely recommend checking that out if you're looking more resources on the like application development side. There's also on that KMM portal, there's a couple other examples. JetBrains has some, there's a couple other community ones. So yeah.
I was gonna suggest if, I know it's a bit of a copy paste exercise for you, but if you could drop some of those links into
yeah, that's a good idea.
Slack channel, that would be great. And I do want to say we're at the 10-minute mark right now. I'm more than happy to give you host permissions now and leave it open. I'm going to stop recording just because we're at the end of our session cut. And if folks want to stay and continue to chat here or want to hop over to Slack, feel free to. There we
go. So I just dropped the link to the new Kotlin Multiplatform mobile portal. So that has a bunch of samples that has like links to different libraries and links to different application samples. Let me catch what other questions were in here. Interrupt performance. I'm
sorry. I just gave you a host permission. I'm sorry to interrupt, Russell. I just gave you a host permission. Could you hit the stop recording button for me?
Oh.
Forgot to do that before handing you the host permission.
Stop recording.